So, good morning to everyone. After a long time we are meeting. I hope everyone is happy and everyone is safe. Okay. Now let's start our session. Okay. So this semester we will be studying automotive systems. I'm handling the subject, and this is a theory subject. It won't be that much of tough. It will be a simple and easy subject. Okay. So no need to worry. So this is a new platform. So in the first class there may be some discomfort or anything, so don't worry and neglect it. Okay, from the next class I hope we can have a good session. Okay, so automotive system, basically it has as as everything, it has 5 units. Okay, it's somewhat completely related to automobile. Okay, it is completely related to automobile. We will be studying about engines, chassis, frames, types of engine, types of automobiles, everything. Okay, so it has 5 units. So in a brief method, we can see the syllabus now. Okay, this is the presentation I have prepared for you. It takes too much long time, so please listen. Okay, so syllabus, the unit 1, it will be the automotive engine auxiliary systems. Okay, in this unit you will be studying about types of engines. So okay, the petrol engine, diesel engine, 4-stroke, 2-stroke, and after that you will be studying valve timing, port timing diagrams, and injection system and ignition system. Okay, the fuel injection system as well as the injection system. Okay, so this is the first unit, and in the second unit you will be studying vehicle frames and steering system. Okay, construction, chassis, layout, and then the steering system, types of steering, gearbox, steering linkages, everything you will be studying in the second unit. Sorry, in the unit number 3, that is the transmission system. Okay, here you will be studying clutch, gearbox, manual transmission, automatic transmission. Okay, transmission systems, fully based on transmission systems. And this is the fourth unit. We'll be studying about suspension braking system. Suspension system, braking means you know, everyone knows ABS, EBD. So all the recent technologies also you'll be studying in the fourth unit. And fifth unit is completely alternative energy source. So nowadays we all know that fossil fuels are depleting. So we are moving towards renewable energy. So that is the alternative energy source. You will be studying in unit number 5. Okay. So now we can step into the first unit. Okay, in the first unit, before starting the first unit, you have to know some basics. So first, what is an automobile? Okay, before entering into the unit, just discuss about what is an automobile. Automobile is nothing but it is an object, okay, which has wheels for its movement and can produce its own power for its propulsion. Okay, an object which can produce its own power for its own propulsion. Okay, that is an automobile. Okay, that's auto means automatic. Mobile means mobility, movement. Okay, so that's where the name has evolved. Automobile means an object which can produce its own power for its propulsion. Okay, basically the automobile is mainly used for transporting objects, passengers from one place to another without any struggle. Okay, for reducing the human effort, for reducing the human strain and stress, the automobile has been invented. Okay, it is for transporting objects or people or passengers or anything from one place to other place without any struggle of human effort. Okay, that is an automobile. Okay, then next one, what is an engine? In every automobile there will be an integral part, engine. Okay, so what is that? What is an engine? Engine is the most integral part in an automobile. It's like a heart of a human. Okay, the engine is the heart of the vehicle. Okay, like the heart of the human, the engine is the heart of the vehicle, because without heart no one can live. So like that, without an engine, automobile is nothing. Okay, so engine is the integral part of the automobile. Okay, the engine is the part in the vehicle which produces the power for the propulsion of vehicle. Okay, the engine is the part in the vehicle which produces the power for the propulsion of vehicle. Okay, here the engine burns the fuel. Okay, air fuel mixture, or okay, yes, the air fuel mixture. Okay, petrol or diesel, anything. The engine burns the air fuel mixture for producing the power, and the engine converts the heat energy into the mechanical energy. Okay, because inside the engine, when expansion stroke happens, huge amount of heat will be produced. Okay, that heat, due to the huge amount of heat produced, there will be a blast will happen inside the engine, and that's why the piston moves up and down. Okay, so that is piston movement, and the crank movement is the mechanical energy, and the expansion stroke, the heat produced, that is heat energy. Okay, the heat energy will be converted into the mechanical energy. That is the purpose of engine. Okay, next one, types of engine. What are the types of engine? There are two types of engine. One is the external combustion engine, it's called shortly called as EC engine, and the another one is internal combustion engine. In short form, it is called IC engine. Nowadays, we all are using IC engine, internal combustion engine. EC engine, external combustion engine, is not in conventional use today. Okay, right. What is the difference between EC engine and IC engine? In an external combustion engine, the combustion takes place outside the engine cylinder. Okay, in engine there will be a cylinder, but in external combustion engine there is a separate chamber for combustion. Combustion means burning the fuel. For burning the fuel, in external combustion engine there is a separate chamber. Okay, the fuel is burned in the external chamber, and then the steam, okay, comes through the tube into the cylinder, where the piston is moved up to and fro by the pressure produced by the steam. Okay, the combustion takes place outside the chamber. Okay, that is the outside the engine cylinder. Okay, that is called external combustion engine. And in internal combustion engine, this is the, we are nowadays using this IC engine, internal combustion engine. Here the combustion takes place inside the engine cylinder. Okay, petrol engine, diesel engines are the best example for internal combustion engine, and for external combustion engine, steam engine is the best example. Okay, so in the next slide I will be showing some images related to external EC and IC engine. Okay, for external combustion engine, this is the steam engine. Okay, here you see we are burning the coal in a separate chamber, that is the combustion chamber, and near the combustion chamber we are placing the water tank, reservoir water storage. Due to the heat produced by burning the fuel in the external combustion chamber, the water gets heat and the steam is generated, and the steam flows through the tube into the piston cylinder, into the cylinder where piston is placed, and due to the pressure in the steam, the piston moves to and fro. Okay, it is directly connected to the crankshaft. Okay, the crankshaft rotates and the power is transmitted to the external drive. Okay, so this is the EC engine, because the combustion takes place outside the cylinder in a separate chamber. Okay, the next slide, you see this is the internal combustion engine, the exact engine setup in a recent automobile. Okay, so in the left end you are seeing the flywheel. Okay, so in the right end there is a shaft which connects all the crankshafts. Okay, so this is the internal combustion engine. Here inside the engine cylinder, the combustion takes place. You will be having inlet valve, you will be having exhaust valve. Okay, that in internal combustion engine there are two types, for petrol engine as well as diesel engine. In petrol engine you will be having spark plug, and in diesel engine you will be having fuel injector. Okay, so here the entire operation takes place within the engine cylinder. Okay, so that's why it is called internal combustion engine. This is the engine we are using nowadays. So next one, types of IC engine. Okay, in IC engine there are many types. That's spark ignition. Yes, first one is SI engine, spark ignition engine. Okay, spark ignition engine means this is the petrol engine. Okay, for petrol engine we are using spark plug. So the spark ignition engine means it is the petrol engine, an engine in which combustion process in each cycle started by using an external spark. Okay, spark ignition engine means this is the engine where combustion takes place by the ignition of spark plug. Okay, this is the spark ignition engine. Here you see you are having the spark plug here, inlet valve, outlet valve, the piston, and in the top you are seeing the spark plug. So next one, this is the compression ignition engine, CI engine, compression ignition engine. Okay, okay, here you see an engine in which the combustion process starts when the air-fuel mixture self-ignites due to high temperature in the combustion chamber caused by high compression. Okay, that's why due to compression the expansion stroke happens. That's why it is called the compression ignition engine. Okay, because in this here you will be having fuel injector. Okay, only the air comes in. Okay, during the piston moves up. Okay, there will be a small area only left. In that area, the air at high pressure is carried. Okay, at that point, the fuel injector injects some fuel. Okay, when pressure is very high, the heat is automatically generated. Okay, in the heated high pressured air, when the fuel is injected, the expansion stroke happens. Okay, that's why it is called the compression ignition engine. This is the diesel engine, simply called as diesel engine. Now, after that, in the same IC engine, we are having spark ignition engine and compression ignition engine, and thereafter we are having two-stroke engine and four-stroke engine. Okay, we are having two-stroke SA engine and two-stroke CI engine, and then we will be seeing four-stroke SA engine and four-stroke CI engine. Okay, now we can see two-stroke SI engine. Okay, two-stroke SI engine means a two-stroke SI engine consists of cylinder with one end fitted with the cover for the placement of spark plug and other fitted with the sealed crankcase, which will act as the leak-proof pump during operation. Okay, the cylinder is provided with inlet port, transfer port, and exhaust port. These ports are opened and closed by the movement of piston only. The exhaust port is located slightly above the transfer port and diametrically opposite. Okay, in the next slide you will be studying the entire operation. Okay, in two-stroke engine it has a cylinder. Okay, the cylinder in the top side of the cylinder there is a cover, cover is placed for covering the top side. In the cover there is a spark plug. Okay, in the top surface in the cover at the center point of the cover the spark plug is placed. Okay, and there is other inlet port, outlet port, and transfer port is available in the two-stroke SI engine. SI engine means this is a spark ignition engine. Okay, in the two-stroke SI engine, these are the components. Okay, and these inlet port, outlet ports are all opened and closed by the movement of the piston. Okay, all the ports are open and closed by the movement of piston. The piston, when it moves up and down, the the particular ports will be opened and closed by the movement of the piston. Okay, and in main thing in the two-stroke engine, in both the SI engine and CI engine, two-stroke engine means the combustion happens in the crankcase. Sorry, combustion happens in the inlet valve. Inlet valve is placed in the crankcase. Okay, inlet valve will be placed in the crankcase. When the air comes in, it goes to the top through the transfer port. When the cylinder pushes up, the air gets compressed, and at that time the spark is produced. Okay, air fuel mixture goes up, the spark plug produces a spark and the combustion happens in two-stroke SI engine. And another one thing, why it is called two-stroke SI engine? Okay, in two-stroke SI engine as well as the four-stroke SI engine, the four operation will happen. The intake stroke, okay, the intake stroke, then the compression stroke, the expansion stroke or combustion stroke, and finally the exhaust stroke. Okay, intake stroke, first stroke. Okay, intake, four operations: intake, compression, combustion, and exhaust. Okay, four operations. But in both four-stroke and two-stroke engine, there are four operations. Then why it is called two-stroke SI engine and four-stroke SI engine? In two-stroke SI engine, in a single rotation of the crankshaft, two operations will complete. Okay, when the crankshaft rotates the one complete cycle, when the crankshaft completes one complete cycle, two operations will happen. Okay, the intake as well as compression will happen at a single rotation of the crankshaft. Okay, and after that, in the second rotation of the crankshaft, that the combustion and the expansion stroke will take place. Okay, in two complete cycle of the crankshaft, the four operations will happen. That's why it is called two-stroke SI engine. But in four-stroke SI engine, For each and every stroke, the crankshaft will rotate a complete cycle. Okay, first the complete cycle, that is the intake. Second complete rotation, it is the compression. Third complete rotation, it will be expansion or combustion. And final complete rotation, it will be expansion. Sorry, the exhaust stroke. Okay, now we can see the two-stroke engine, two-stroke SI engine. Here you see in the first stroke. Here you can see the exhaust gas just below. In the left side diagram you see the exhaust gas, exhaust port, that is just below the exhaust port. There is one opening, that is the intake, inlet port. In the right side of the diagram you can see there inlet port. Okay, when the piston is at the top, TDC means top dead center, at the top surface. Okay, top dead center. Okay, when the piston is at the top dead center, you see in the diagram itself you can see in default the exhaust port will be closed by the piston. Okay, as well as the transfer port will be also closed. Okay, the transfer port as well as the exhaust port will be closed when the piston is at the top dead center, so that by default the inlet valve will get open. Okay, the inlet valve will get open. So when the inlet, so okay, as soon as the inlet valve gets open, through the inlet, what the air fuel mixture comes in. Okay, the air fuel mixture comes in. How will you get air fuel mixture? By the use of carburetor. Okay, nowadays the carburetor has been replaced. We can see afterwards. Okay, I will explain afterwards. That's what, that one. So here we are seeing the basic things. Okay, so when the inlet valve opens, from the carburetor you will get a fresh air fuel mixture. Okay, when the air fuel mixture comes in, it comes into the crank case. Okay, where the crankshaft is located, the air fuel mixture comes in. Okay, after that, okay, when the air fuel mixture comes in, the crankshaft will rotate for half revolution. In the remaining half of the revolution, the piston starts to move down. Okay, it will move from top dead center to bottom dead center. When it moves down, okay, the inlet valve gets closed. Okay, as well as what from that from the through the transfer port, the air fuel mixture goes to the top of the okay engine cylinder. Okay, top of the cylinder. Okay, and then when the cylinder again, when the okay, that is called, the air goes up and the piston suddenly moves up. Okay, moves up, the piston again moves to the top dead center, and so the air fuel mixture in the top of the cylinder gets compressed at a high pressure. Okay, first the air from the inlet valve comes to the crankcase, and when the piston moves down, it moves to the top of the cylinder through the transfer port, and when again the piston comes up, the air fuel mixture at the top of the cylinder gets compressed. Okay, gets compressed. When the cylinder is at the top dead center and the air is at the high pressure, compressed air, the spark will be produced. Okay, spark will be produced. At the same time, the inlet, through the inlet valve, the air will also comes in. Okay, a fresh air will comes again. Okay, so you see here, in the first stroke will be, don't confuse, I will explain clearly. In the first stroke, that is the intake stroke and compression stroke. Okay, when the piston is at the top dead center, through the inlet valve, a fresh air fuel mixture from the carburetor comes in to the crankcase. Okay, and then when the piston comes down, through the transfer port, the fresh air fuel mixture goes to the top of the engine cylinder. Okay, and again when the piston moves up, the air fuel mixture at the top of the cylinder gets compressed at a high pressure. Compressed at a high pressure. Where when there is a high pressure is created, there will be high heat automatically. Automatically there is a high heat will be produced. Okay, and due to the high heat, and at that point, with the help of spark plug, a spark will be ignited. Okay, spark will be produced. Okay, already there is a high pressure and heat, and at that point when the spark is produced, there will be a sudden explosion which happens in the cylinder. That is the second stroke, expansion as well as exhaust. Okay, this is the same first stroke. In the second stroke, you see, when the sudden expansion happens, the piston will move down at a high speed. Okay, the piston will move down at a high speed, and that is the power stroke. Okay, expansion stroke is the power stroke. At that point, the power will be transmitted from the crankshaft to the propeller shaft. Okay. Hmm? So when the piston moves at high speed down, the expansion stroke happens, and there will be smoke inside the cylinder. Okay, the fuel burns and there will be a smoke. Okay, again the piston comes down. So free at that point, before itself, what through the inlet wall, the fresh air fuel mixture also it came in. Okay, simultaneously the final operation exhaust stroke happens simultaneously. When the piston moves down through the transfer port, the exhaust will be open and the smoke will be going outside. It will be not completely gone, it will be going outside, and through the transfer port again the fresh air fuel mixture comes up to the top of the cylinder. Okay, so that fresh air fuel mixture will also drive the smoke inside the cylinder out through the exhaust valve. Okay, it will also push the smoke to the outlet. At that time, there is a possibility of some unburnt fuel which escapes through the exhaust valve. Okay, that is the major disadvantage in the SI engine. The fuel efficiency will be low, but the power production will be high. Okay, so see the complete explanation. Okay, in the beginning of the first stroke, the piston is at the top dead center. Okay, and charge. Compressed charge means the mixture. That is, the mixture of petrol vapor and the air is available in the combustion chamber. In this position, only the inlet port is kept open and the other ports are closed. Okay, the mixture of air and petrol vapor is sucked into the crankcase due to the vacuum created by the rotation of crank. Okay, due to this upward movement of the piston, when the compression is in progress at this position, the spark, okay, at the compression point, okay, the spark plug ignites. Okay, the spark plug ignites, the spark will be produced. Okay, this releases a hot gas with which increases pressure in the cylinder and force is given to the piston. Okay, that is the explosion happening. Okay, when the explosion happening, okay, high heat will be produced as well as what the heavy force, pressured force is given to the piston. That's why the piston starts moving downwards at a high speed. Okay, now it's a second stroke, that is the expansion or exhaust. During the downward travel of the piston, the inlet port is also closed, due to which the mixture gets compressed inside the crankcase and the exhaust port gets opened about 70 to 75 degree from the bottom dead center. You will understand this in the valve timing diagrams. Okay, valve timing and port timing diagrams, you will understand this concept clearly. The angle which is given, which means the crankcase is rotating. Okay, the engine's bottom crankcase will be a circle. Okay, in that circle there will be some lines for mentioning the angles. Okay, due to that angle, at that point the 70 degrees from bottom dead center, 70 degrees from top dead center, the valve opening and closing will happen. That's why they are mentioning here. Okay, so simply first stroke, intake and compression. Okay, so when the piston moves down through the inlet wall, the fresh air fuel mixture comes in, and when the piston continuously moving down through the transfer port, the air fuel mixture goes to the top of the cylinder. Okay, suddenly when the piston moves up, the air fuel mixture at the top of the cylinder gets compressed. Okay, gets compressed, and the high pressured heat area will be produced at the top of the cylinder. Okay, top of the cylinder. At that point, with the help, second stroke begins. Second stroke means expansion as well as exhaust. In the expansion stroke, at first the spark plug produces a spark. With the help of that spark, the pressured air fuel mixture explodes and expansion happens. Okay, the air fuel mixture gets completely burned and a high pressured forces will be given to the cylinder, given to the piston. Due to this heavy force, the piston starts moving down at a very high speed. Okay, and the smoke will be remaining in the top of the cylinder. Okay, and when the piston moves down and again it comes up. Okay, when the piston moves down, simultaneously through the inlet wall, the fresh air fuel mixture comes to the crankcase and continuously moving down, and through the inlet port, the transfer port, the fresh air fuel mixture comes to the top of the cylinder, which will push the remaining smoke in the cylinder through the exhaust valve. Okay, and again the piston comes up, okay, and then that air fuel mixture which came in get compressed as well as through the exhaust valve. While pushing the exhaust gases, some amount of fresh air fuel mixture may also escape through the exhaust valve. Okay, some unburned fuel gets escapes through the exhaust valve. Okay, that is a major disadvantage in the two-stroke engine, and this cycle continuously happens. Okay, so there will be a efficiency loss in two-stroke SI engine. Okay, now two-stroke CI engine. This much times we have studied about two-stroke SI engine, spark ignition engine. Here we are studying about two-stroke compression ignition engine. Okay, the operation of two-stroke CI engine is completely similar to two-stroke SI engine. Okay, in two-stroke SI engine or diesel engine, the cylinder is provided in the inlet port. Sorry, the cylinder is, there is a cylinder and there is an inlet port and there is a transfer port, there is an exhaust port. Okay, all the ports are closed and opened by the movement of piston, the same thing. Okay, all the ports are opened and closed by the movement of the piston, the same thing. So this is the complete operation for two-stroke engine, for both two-stroke engine as well as two-stroke SI engine as well as two-stroke CI engine. The only thing, if you consider that as a spark plug at the top, this is the two-stroke SI engine. If you consider that as a fuel injector at the top, this will be the two-stroke CI engine. Okay, you see the green arrow here, the right side bottom, that is the inlet valve. Okay, the inlet valve, through the air comes in. Okay, simultaneously the compression, combustion as well as the through the transfer port, the fresh air goes above. This is the exact video demonstration for two-stroke engine. Okay, this is the exact video demonstration. Okay, moving on to the next slide. Here, first stroke, the same thing, intake stroke as well as compression stroke. In the beginning of the first stroke, as same in the two-stroke SI engine, here also what, the piston in the top dead center starts moving down. At that point the inlet valve is opened, and through the inlet valve here you will be getting only the air, only fresh air. Okay, in SI engine you will be getting air fuel mixture through the inlet valve, but here you will be getting only the fresh air. Okay, here you will be getting only the fresh air through the inlet valve. Okay, through the inlet valve you will be getting only the fresh air. Okay, and then through the transfer port the fresh air goes to the top of the cylinder. Okay, and again when the piston moves to the top dead center, the fresh air in the top of the cylinder gets highly compressed, and a high temperatured pressure is created in the top of the cylinder. During that point, okay, this is the first stroke, intake and compression. Okay, intake and compression. In the first stroke, intake and compression. Here you in CI engine you will be getting only the fresh air through the inlet port. Okay, and when the piston moves down through the transfer port, the fresh air goes to the top of the cylinder, and again when the piston moves up, it compresses the compresses the fresh air in the top of the cylinder and produces a high pressured heat area in the top of the cylinder. Okay, this is the intake stroke as well as compression stroke, first stroke. In the second stroke, expansion and exhaust. Okay, due to high pressure at that point, the fuel injector injects the fuel, that is a diesel. Okay, fuel is diesel. It injects the fuel. Okay, it sprays the fuel in the high pressured heat area. Due to the fuel mixing with high pressured air, expansion stroke happens. There will be a blast inside the cylinder. Okay, the blast happens. This is the power stroke, and the same, the high amount of pressure is given to the piston, and the piston starts to move to the bottom dead center at a very high speed. Okay, very high speed, and this power is transmitted through the crankshaft to the propeller shaft. Okay, this is the expansion stroke. And similarly the exhaust stroke, what, again the fresh air comes in. Okay, at the same time the outlet valve will be opened, the smoke in the top of the cylinder will be going out. Simultaneously the fresh air from the crankcase, through the inlet valve and in the crankcase, through the transfer port, the fresh air comes to the top of the cylinder. Some fresh air will that fresh air will also help the smoke in the top of the cylinder to go out. Okay, the fresh air pushes the smoke outside. Okay, at that time, some of the fresh air may also escape through the escape through the exhaust valve. Here also there is a loss of fresh air. Okay, there will be loss of efficiency. This is the compression, two-stroke compression ignition engine. Both are completely same. The only thing, in two-stroke SA engine you will be having spark plug, and two-stroke CA engine you will be having fuel injector. And the second thing is, in two-stroke SA engine you will get a air fuel mixture from the carburetor, and here there will be no carburetor. In two-stroke CA engine there will be no carburetor. You will get fresh air, only the fresh air. The fuel will be mixed at the point of expansion stroke. Okay, fuel injector, only through the fuel injector the fuel will get injected during the expansion stroke. Okay, this is the difference between two-stroke SA engine and two-stroke CA engine. Okay, so next slide. Now working of four-stroke SA engine. Okay, this is the conventional engine. Nowadays only the four-stroke engine is in use. Okay, nowadays in all the automobiles, two-wheelers, four-wheelers, everything, we are using four-stroke SA engine. Two-stroke SA engine, the best example is Yamaha RX100. It will produce some extra smoke. Okay, the pollution will be high in two-stroke engines. In four-stroke SA engine, the complete burning of fuel happens. Okay, complete burning of fuel happens in two-stroke four-stroke SI engine. Okay, simply telling, in two-stroke SI engine incomplete combustion, in four-stroke SI engine complete combustion. Okay, four-stroke SI engine, there will be four separate steps. One, complete revolution of crankcase, suction stroke or intake stroke. Another, second complete rotation of the crankshaft, that is compression. Then third complete rotation of the crankshaft, expansion stroke. Fourth complete rotation of the crankshaft, that is the exhaust stroke. So here the time given for burning the fuel, intake, exhaust, everything is somewhat higher when compared to two-stroke engine, and the same thing, at the same time you will get complete burning of fuel. Okay, so that the efficiency of the engine is high. Efficiency of four-stroke engine is high, efficiency of two-stroke engine is low, but power produced by two-stroke engine is high and power produced by four-stroke engine is low when compared to two-stroke engine. Okay, so here in four-stroke SA engine, you see, first stroke is suction stroke or intake stroke. Okay, during this, at the intake stroke, the inlet valve gets opened. Okay, the inlet valve gets opened and the piston starts moving from top dead center to the bottom dead center. Okay, the piston starts moving from top dead center to the bottom dead center. Through the intake valve, the fresh air fuel mixture comes in. Okay, the fresh air fuel mixture comes in. This is the intake stroke. Okay, the fresh air fuel mixture, you will get the fresh air fuel mixture from the carburetor. Okay, due to the rotation of the piston, movement of the piston, the same thing, the vacuum happens in the cylinder. That's why when the intake valve opens, the fresh air fuel mixture suddenly comes in through the intake valve to the cylinder. Okay, at this point the piston moves from top dead center to the bottom dead center, complete movement. Okay, so complete movement, the inlet valve will be opened and continuously the air fuel mixture comes in until it fills the cylinder. Okay, and here in this carburetor, the air and fuel will be mixed at the perfect correct ratio. Okay, second stroke is compression stroke. Compression stroke means what? Only the compression process happens. Okay, high pressure area will be created at the end of this stroke. Okay, at this point the piston starts moving from bottom dead center to the top dead center. Okay, at this stroke the piston starts moving from bottom to top. Okay, bottom dead center to the top dead center. Okay, in this stroke, the above the piston, the entire area you will have the air fuel mixture. Okay, when the piston moves up, it it compresses the complete air fuel mixture in that area. Okay, at that, when the piston reaches the top dead center, in the small gap, the large amount of air fuel mixture is highly compressed to the high pressure. Okay, highly compressed. When highly compressed, at that area, high amount of pressure will be produced. Okay, the high amount of pressure will be produced, and the complete air fuel mixture get compressed at the top of the cylinder in the top dead center area. Okay, at that point, the spark plug produces a spark. Okay, at that point, the spark plug produces a spark, and the next stroke begins. Next stroke is combustion stroke. Okay, when the spark plug produces the spark, the compression stroke happens. Combustion. Okay, sorry, compression, not combustion stroke. Sorry for my mistake. Okay, combustion stroke happens. Combustion of air fuel mixture occurs in a very short but finite length of time. Okay, when the expansion happens, the spark continuously gets produced. Not only a fraction of second it produces. Okay, it produces for a particular amount of time. Okay, at this stroke, when expansion happens, okay, the air fuel mixture is getting burned, and the high amount of pressure is given to the piston, and the piston is forced to move down. Okay, move down at a high speed. Okay, from the top dead center, the piston is forced to move down at a high speed to the bottom dead center. Until the piston reaches the bottom dead center, the spark will be produced. Okay, until the piston reaches that bottom dead center due to high pressure, the spark will be produced continuously. Okay, this is the expansion stroke, or it is called the power stroke. Okay, when spark gets produced, the air fuel mixture gets ignited, and a blast happens inside the engine cylinder, and the high amount of pressure is given to the piston, and the piston is forced to move to the bottom dead center at a high speed. Okay, and this is transmitted, this movement is transmitted to the propeller shaft through the crankcase, clutch, gearbox, everything. Okay, the last stroke is exhaust stroke. Exhaust means after the complete burning of fuel, what smoke? Smoke remains inside the cylinder. Okay. At this point, when piston moves from bottom dead center to top dead center, as well as the exhaust valves get open. In the fourth diagram, you see the exhaust valve is open. Okay, the exhaust valve gets opened, and the piston moves from bottom dead center to top dead center. Okay, and this piston completely pushes the burned gas. Burnt gas means the smoke. Completely pushes the smoke to the outlet through the exhaust valve. Okay, so that when again the inlet valve opens, the fresh air fuel mixture comes in. So there will be no loss of no loss of fuel, no loss of smoke remains inside the cylinder, and so there will be no problems. Okay, and you see at the last end, when the piston comes when the piston comes moving up, until it reaches when it comes near the top dead center, the exhaust valve will also open for moving the smoke to the outlet valve, as well as the inlet valves get opened for getting the air fuel mixture. At this particular point, okay, the inlet valve and the exhaust valve both will remain open for a particular fraction of time at the end of the fourth stroke, and this is called the valve overlap. The last sentence, you see this period of both intake valve and the exhaust valves open is called the valve overlap. So this is one of the important two mark. Okay, valve overlap. In the last stroke, exhaust stroke of the four-stroke SI engine and four-stroke CA engine. Okay, at the ending of the exhaust stroke, okay, that both the inlet valve and the exhaust valve will be opened for a particular fraction of time. Okay, and this is called valve overlap. And the next one, four-stroke CI engine, four-stroke compression ignition engine. Okay, so what is the time now? Is it almost 45 minutes. So I can present only for 45 minutes. Okay. So after that, you will be having some, you can ask me some questions for the next 45 minutes. So we can discuss, we all can discuss. Okay. Uh, right. I don't know how much time I took class, how much time it went. So wait a minute, I will come now. Right, okay. I don't know the time exactly. There is a shortage of time. Sorry. Next time I will note the time correctly. Okay. Stop sharing. So if you have any doubt, you can ask now. Okay. So this is not that much of tough subject. This is a easy one. I will give you the exact notes shortly. Okay. I will give the notes which will be easy for preparation. I will give shortly. Okay? So thank you. The next class we can study the remaining. Okay, remaining.